Hello everyone. In this video we will talk about DataFrame methods. So you can access all the methods. I have created a list. Go to the blog, go to my YouTube channel, then go to the blog. Here you will click on 12th Informatics Practices. Then under DataFrame, Pandas DataFrame, you will find DataFrame methods. So these are all the methods of DataFrame. We will see these methods one by one. So let us start with ABS. I have created this data frame. You can check how I created it. I have imported pandas and numpy. Here I am creating a 2D numpy array. I am creating a numpy array using arange with 16 elements and I am making it a 4 cross 4 using reshape. Then I am passing this array into data frame function, so my data frame will be returned in df. You can see this is my data frame. So I will perform all the operations on df. So let us see and check first function, that is abs. So abs is a mathematical function which will return absolute values of all the elements of data frame. If my data frame is df, then I can use abs as df.abs. If I click enter, then it will return all the absolute values. Absolute means all the positive values. If any of the value is negative, it will return the positive number of that value, because I had all the values in data frame as positive values. So the same data frame returned by the abs function. Consider if my data frame was having some negative values. Let us make some values negative. How to make it negative? I will access 0th index by 00 and I can assign it with some value. Let us say I have assigned it with minus 55. Then I will access it using df. You can see now my first value has become minus 55. I can use now this df dot abs. You can see it has returned a positive value. So abs method will return absolute value. Absolute is a mathematical term that returns positive values. Let us move to next method, that is add. So add is used for addition. If I want to add 1 to all the elements of data frame, then I will use df plus 1. So it will add all the elements with 1. This was negative 55. The one more thing you should remember, that df.abs will not change the data frame. It will print the changed value. If you want to change the data frame, you have to use df equal to df.abs. So I have not used that. So this will print the absolute values on the screen only. That is why my df was with minus 55. So if I want to add plus 1 to all the elements, I will use this, because data frame performs vectorized operation. So whatever the mathematical operation I perform, it will be applied to all the elements. Same way you can use add function to add something. So you can see the same result has been returned. So whatever functions we will use, those functions will print the output on the screen and will not change the data frame. You can see this. Add also will print the output on the screen. If I check the df again, the df will be minus 55 or all the values as previous. But if I want to change it, I have to do df equal to df.add. I can add two data frames also. Let us run this again. Okay, let's take a df2 by this. Df2 equal to df.abs and my df will be, I will run it again. So df will be assigned with these values again. So now you can see my df is this and df2 is this. See these values. So I can perform df plus df2. So it will add df and df2 both. So this thing I can do with the help of add function also. Dot add. This will give me the result. So it is similar to df plus df2. Now let us move to our next function, that is div. So div is used for division, a mathematical division. So again I can divide my df, this is my df, by 2 like this. So I can use in place of this df dot div then 2. So it will divide all the elements by 2. I can divide two data frames also by using df dot div df2. So it will divide all the elements of data frame 1 to from data frame 2. So it is similar to df by df2, and it is similar to this is similar to df divide by 2. So this is division function. Let us move to next function, that is sub. Sub means subtract. If I want to subtract something from my data frame, I can use minus operator. Also I can use sub method sub. This will give me same result. You can use it with two data frames also. This is df minus df2. Okay, move to next method, that is sum. So sum, consider this data frame df. So it is having 4 rows and 4 columns. So what sum method will do? Sum method will return the sum of all the columns. Listen it again, all the columns. Sum. So it is returning the sum of all the columns. Check the df again. So this is my df. It is returning sum of all the columns. If you sum the 0th column, so it is 12 plus 8 20 plus 4 24. If you add number of column number 1 2 3, this will return the same thing. It is returning the sum in the form of series. So this is your sum function. Also there is in one axis, you can change it. Let us try it with next example. I will remove it from here. I will try it here. You can give rows. So it will give you the sum of different. If you give x is equal to rows, that means all the rows. If in the column 1 0 1 2 and 3, so it will be returned in 0. If I change it to columns, so it will give me the sum of column wise sum of columns. So all the columns at row number 0, first column, second column, third column and fourth column, the sum is 6. So you can use axis parameter to print the sum of row wise and column wise. You must remember, if I give rows, then it will print the sum of column wise sum of different rows. And if I give columns, then it will print row wise sum of different columns. So you must remember that. Let us move to next function, that is floordiv. Floordiv is a floor division. If I want to divide 5, floor division 2, then it will give me 2. It will return the floor division. So if I have data frame df, then I can divide floor div 2. It will return me this output. I can use df2 also. So the df will be floor divided by df2. Let us move to next function, that is equals. Equals is used to check whether two data frames are equal or not. So if I want to check df is equal to df2 or not, element wise I will use equal to sign. And if I want to check whether two data frames are equal or not, so if all the elements are true, element wise, then it will return true. Df dot equals df2. I will run it here. You can see equals equals. Okay, it is returning false because not all the elements was same. If I do it df equals df, that means df is equal to df because both are same data frame, that is why it is returning true. So you can check two different data frames whether those data frames are equal or not. If those are equal, then it will return true, and those are not equal, if any of the element is different, then this equals function will return false. Now see the next function, which is all. So all works column wise in the data frame. So all will check column wise data. If all the elements are true, then it will return true for that column. So consider this df. It is having all the numerical elements. Okay, so we have checked this. So let us take df3 from this data frame. So now I am having df3 as this, which is having all the boolean elements. So I can check df3 dot all. So you can see for column number 0, it is giving false because one of the elements in this column is false. For all the other columns, all the values are true. That is why for all the other columns, the value which is returned by all function is true. Also, all function can work with numerical data also. If all the data are non-zero, whether it is positive, negative, any value. So if it is non-zero for any column, then it will return, all function will return true for that. So I will use df dot all. You can see for the column number 1, the value, one of the value is 0, that is why it is returning false. For all the other columns, none of the value is 0, that is why my output is true for all the other columns. So all function will work with boolean data as well as integer data, and in data frame it will work column wise. Now let us see our next function, which is append. So append is used to append one data frame to another. I am having df this, and you can check df3 this. So I can use df dot append df3. So df3 will be appended to df, but since the data frame df was in integer format, so all the boolean data has changed to integer format. So for false it is 0, and for true it is 1. Let us try to add two integer data frames. I am having df this, df2 this. So I can combine df dot append df2. So you can see it has combined. You can combine or append two data frames column wise, one after the other, using append function. Next method is astype. So astype is used to change the data type of data frame. I'm having df is this, and if I check the data type using d types, so I'm having int 32 for all the columns. So I can change df data type using s type, then I will give my int type as int64. So it has returned this data frame, and if you want to check, let us take it in df4 and we will check the data type of df4. My df4 is this, and if I check the data type d types, so you can see my data type has now become int64, which was previously int32. So you can change the data type using s type. Let us move to another function, which is copy. So copy is very similar to, if I am having df is this, so I can make df5 using df as df5 equal to df. So my df5 will become as df. So all the values of df is copied into d5. So same way I can do it using copy function. So all the values of df will be copied to df5. It is very similar to equal to sign. Now let us move to next function, that is describe. So describe function will return the statistical data of the data frame. If I am having df5, then I can use describe as this. I will just call it. So you can see for all the columns, describe will work column wise. For all the columns, it has returned count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, max in all the columns. So you can use describe function to check the data column wise, check the statistical data column wise. So this is my describe function. Here you can use this bracket to find data for a particular column. So for column number 2, the data is this. And our next method is drop. So drop the rows or columns from the data frame. So if I am having df is this, so I can drop rows or columns from this data frame. If I want to drop column number 1 and 3, I will give a list in the column parameter 1 comma 3. You can see now my column 1 and 3 has been removed. Also, if I want to remove some rows, I can drop rows using drop function. Drop, I will give rows, and in the list I will provide my data frame df was this. If I want to remove row number 2, so I will give 2 in the list. Okay, so for single, okay, so there is parameter name is index, so I can remove index number 2 using give parameter index. So I can give it in the form of list also. So list is used when I want to give more than one parameters, one rows, more than one rows. So I want to remove 2 rows, so I can give it in list. So the parameter is index for removing rows, and to remove column, the parameter is columns. I can use both of these together. So index is equal to 0 if I want to remove 0th row, columns equal to 1 if I want to remove column number 1. You can see 0th row is removed and column number 1 is removed. You can give it in the form of list also. If I want to remove 2 columns, I will give 1 comma 3. So my 2 columns has been removed and only a single row has been removed. So this is my drop function. My next function is drop duplicates. Drop duplicates. So drop duplicates is used to drop the duplicate values. My df3 was this. So drop duplicates will drop the rows which is having same value, duplicate value. You can see there are 4 rows. Out of 4 rows, 3 are similar. So out of these 3, my drop duplicates will keep a single row with all the elements and will remove the 2 other rows. So df3 dot drop underscore duplicates. Now you can see all the other rows with same value has been removed. So it will remove duplicate rows. Next function is drop na. Let us make another data frame df5. I will make this data frame as a number data frame with some values with nan. So consider this data frame. L is the list. Then I will provide df5 as pd dot data frame then L. So I am having df5 now. This I will make some of the elements as nan. Now check this df5. Two of the elements are nan. So drop na will drop all the rows which is having nan. Nan is not a number. So if I use df5 dot drop na, so all the rows with nan will be removed. You can see there were 2 rows with nan, so both the rows has been removed and only single row is remaining that is not having any nan value. Another function is fill na. So fill na is used to fill the nan values. I am having df5 this. So if I want to change all the nan values with some particular value, then what I will do, I will use fill na. That means fill all the nan values. I am giving 99, so all the nan values will be changed to 99. So this is the working of fill na. Our next function is replace. Replace will change the particular value to some other value. I am having df is this. So okay, consider the df5 only. I am having df5 is this. So if I want to change, okay, I will make df6 out of this. So I am having df6 is this. Okay, so there are two 99s. So if I want to change this 99 to some other value, so I will use df dot replace 99 comma 555. So it will change, okay, df6. So it will change it will find all the values which is 99 in the data frame and make it to 555. So replace is used to change or replace all the values in the data frame to a particular value. It will find this value and it will change to this value. Next function is rename. Rename is a function which is used to rename the index or column position. Rename the index name or column name. So I am having df this. So there is column name 0123 and row name 0123. If I want to change this default name, I will use rename and to change the row name, I will use index equal to, and in the dictionary form I will provide the, if I want to change 0th and 3rd index, I will provide a dictionary format here where key will represent the current index and the value will represent the new index. So if I hit enter, you can see now it has become A and it has become C. I can use column parameter to change the column name also. I will change the column number 1 to X. The parameter name is columns. So now you can see it has changed to X. So this is my rename function, which using which I can change index name, column name, or either of them. The next function is reindex. Currently you are seeing that I am having df as this. So I can reindex the rows. Index means rows. So I can reposition them. If I want this index position 1 row should come at the first and 0 row come at the last, I can use reindex function df dot reindex. Then inside this I will provide a list of indexes for new position. So I want one number at the first position, then 2, then 3, and at the end 0. So you can see all the position has changed. 0 gone to the last position, first, second, then third. So this is the working of reindex. Next function is reindex like. So you have changed this index according to your need. Let us make to df6. So I am having df as this and df6. See the indexes for both the df and df6. It is having 0 1 2 3 and it is having 1 2 3 0. So reindex like is used to make the indexes of a particular data frame like the other data frame. If I want to make changes in the data frame df6 and I want to reindex the position of indexes according to as it is in df, so I will use df dot reindex underscore like. So all the positions of df6 will be same as df. You can see now it has changed to similar to df. So if the index name of two data frame are same, you can use reindex like. So all the indexes of one data frame will become similar to the other data frame. It is not compulsory that all the data inside this data frame is same, but the index name should be same. So all the indexes of one data frame will become similar to other data frame. The next function is rename axis. Consider this data frame df. This column and row, these both are my axes. This is row, axis of row, this is axis of column. So I can give the axis names. So let us see how to give the axis name. I will use rename underscore axis. I will give this axis name. Let us give the indexes axis name. So I will give this axis name as my index. So here one is the one parameter we have to provide. So I want to change the axis row axis name. I want to assign row axis name. You can see now it has given my index to this axis. I can give the name to column axis also. So in the df7 it is having row index name. Now let us give the name to column axis. So df dot rename underscore axis. Here I will give my underscore column, and axis I have to give as columns. Now you can see the name of this column axis is my column, and my index is the name of this axis, row axis. So using rename axis, you can change the column axis or row axis name. Next is set index. Set index function will use to set the index of data frame. Consider this data frame df. Now if I want to make the indexes, index means this row index, these are called index in data frame and these are called columns. So if I want to change index and want to make the same as one column, let's say I want to make index of this particular data frame as 3, 7, 11 and 15, that is similar to column number 3. So what I will do, I will do df dot set index, and here I will provide df number column number 3. So you can see now my indexes has become column number 3. So column number 3 has become my indexes, and the name of it is my column name. You can make any of the column as your index, because sometimes we want some of the columns to become as index, like in case of employee data frame, you want your employee id should become your index. So it will save your space for one column, as well as it will be easy to work on that data frame, because your index will be your employee ID of your data frame, of your employees. So this is the working of set index. Next function is where. Where, this is important function, and last time it was asked in one of the sample question paper of CBSE board. So this is important. So where, this is a little tricky function. So where is used to change the values which are not matching with the condition. If I am having data frame df, if I do df is greater than 2, so for all the values which are greater than 2 will become true, and all the values which are not greater than true will become false. So what where will do, df dot where df is greater than 2, so make them 99. So all the values which are false will be changed. So this is very important. So where will change the values which are false, which are not matching with the condition. So this is the working of where. Next function is max. So max will provide you the maximum value of each column wise. If you want for a particular column, you can give it here. So it will give the particular column maximum value. If you want all the columns maximum value, you will give df dot max. Next function is min. So similar to max, I can find min by doing df dot min. So it will give minimum from all the different columns. For particular column, I will provide in square brackets. Next function is mean. Mean will provide average. Mean will provide average of different column wise average. Median will give the median, column wise median of all the values. Df dot median. So column wise median will be printed. Next is standard deviation, STD. So STD function will give the standard deviation again column wise. So everything will happen column wise. So column number 1 standard deviation is this. So it will give the column wise standard deviation. Variance where column wise variance. This is column wise variance for a particular column. I can provide here count df dot count. It will give the count the element column wise element. For a particular column you can count the element by giving this agg. Agg is a aggregate function. We have used this, if you remember, sometime before I have used describe function. So it will describe these terms and will provide you column wise values. If I want particular values, not all the values, then I can use agg function. Here I can provide it in the list. If I want min and max only, then I will give min and max. If I want sum also, then I will give sum. So it is giving me min, max and sum. So this is the aggregate function. Next function is head. So head will give the 5 default rows from the above, because there are 4 rows only, so it is giving 4 rows from the data frame. I can change this. I can take the 2 rows from the top using head 2. Next function is tail. So tail will give the rows from bottom. The default is 5. I can change the value. If I want 3 rows from the bottom, I can extract it using df.tail3. So it is giving me 3 rows. So these are all the methods of data frame. Practice these methods. It is very simple, and these methods we will use in coming operations of data frame. If you have any doubt, you can ask me in comments. We will meet in next video. Thank you.